Good morning, one and all present here. On behalf of our CSE department, I welcome all the participants for this FDP on day 2, latest trends and challenges in IT industry, organized by the Department of Computer Science and Engineering, R.M.D. Engineering College. I thank our management, our principal, head of the department for giving this event today. I have immense pleasure to welcome our today's guest speaker, Mr.B.Ekambaram, Cloud Engineer, Philips, Bangalore. I take this opportunity to introduce our today's guest speaker, Mr.B.Ekambaram. Mr.B.Ekambaram completed BE Computer Science and Engineering in 2014, worked with TCS for 3 years as software engineering in mainframes, and in AWS Cloud Bean as a trainer for freshers in TCS. Worked then with Thermo Fisher Scientific for about 1 year in AWS Cloud and DevOps. Currently working in Philips as cloud engineer. Now I request Mr. B.Ekambaram to take over this session. Please, sir.
Thank you very much, ma'am. So I am actually immense pleasure to share my knowledge regarding cloud computing. So let me start share my screen and present you the topic. Okay, hope the screen is visible for everyone. So let me start with cloud computing and what is it all about. And my agenda would be to let you know what cloud computing is and also related to how cloud is actually working in today's arena and how we are wishing to use cloud computing in an efficient way and what are the various methodologies and factors which are to be known when we are trying to use cloud computing. And I'd also make sure like I can give a small demo with Amazon Web Services in one of the services with AWS so that it would be known like, okay, so how easy it is to you get with cloud computing and how we can use it in a better way. Okay, so what is cloud computing all about? We need to know like this is actually not a technology which is very recent or which has come up in a very shorter period of time. It was actually from 1960s this cloud computing was existing, but on a clear picture it actually came better over this 21st century only, and it is actually having a rapid growth wherein all these days in IT sectors we were working with all softwares, different kinds of software, different languages and everything. But this cloud computing has made something better wherein we are trying to use hardwares in the means through software technologies so that how hardware technology can be efficiently used in a better way than not in a physical means but also in a logical way through softwares. So while going through it, I just wanted to have a good word about to understand what cloud computing is. So it is not something that we are going to buy something and have it, but we are just going to pay for what you're going to use it. This is similar like how we are going to I'll just have one common example almost over the session, which would actually have a great interrelation with cloud computing so that it would be an easy understanding things with the real-time scenarios. So what I would just take is, for example, when we are trying to own a house, we try to build the house, we involve so much expenditures on it, and finally when the house is up we are going to use it, and once we are not going to stay in the house, maybe after some time or thing we again need to sell it back, and the same thing goes across. But just think of a scenario wherein you're going to rent a house, and while renting the house you're just going to pay some small amount as a reservation amount, and then you're going to pay as a rent of how much you're going to stay there.
Hey,
So that is almost the same concept working out here also. So the major idea here is we are not going to buy anything, but we are just going to pay for what we are going to use it. So as you see in this picture, you're going to have the access of cloud computing over varied amount of resources, like let it be a desktop, let it be a laptop, let it be a palm top or a kind of a tablet, and also mobile devices. And even there are servers also, which is being used here. So I just wanted to give a brief thing about a words told by Jeff Bezos, who is Amazon's CEO. So we need to understand here what important thing is, like he was Amazon was actually in part with cloud computing over 2000, that is the 21st century, and it has made a rapid growth, which you will come to know in the upcoming levels. So he just told some few words in an important way. Like he told, like, we are not going to generate our own electricity, but we are able to use it, and we are just paying for what we are using it. So that is how we are trying to use the computing also. Computing in the other way, like we have all our server rooms. If you see, we have it in our college itself. So how these server rooms are operated, how these servers are managed, so what is actually involved in the server. So not on a high level, but on a I mean, like on a basic level, if you wanted to understand, just think about your laptop itself. How your laptop is working. Your laptop is actually measured based on something called as RAM or a ROM, or even the capacity, which is actually, so all these comes under the terminology called as computing. So this computing, we are not going to generate it when we are using it cloud, but we are just going to rent it and use it based on our requirement only. So it is on a varied range from zero, even from 0.5 MB of RAM you can start using, to even more than hundreds of GB is available with the power of computing in cloud. So to understand the definition and to make it easier to make things well, so I have just segregated the basic definition which they have given for cloud computing. So first thing we need to understand about cloud is, it is actually not a product, but it is actually a service being provided to you. So in a similar way, if I wanted to tell you, see, for example, if you are going to rent a house, like for example, you are the owner of the house and you're going to rent a house, you're going to provide some service to the people who are going to rent the house and use it. So that is called as something called as a service. But when you consider as a product, we are going to buy our own house and we are going to use it. So that is something called difference between considerably like a service and a product. Very much related term with respect to colleges is like, when after colleges, like students are going to their career perspective, they are actually defining the companies in two different zones also. So that is like service based companies and product based companies. I think you would have heard these terminologies easily. So how they are working on a differential basis, why they are called as service based and why they are called as product based. So product based is something like they have their own technologies, they have their own products and everything they own by themselves, and they are going to project it outside. But when it is going to be services, it is being owned by some product based companies, and they are going to render it as a service. Like for example, we have these TCS, Infosys, all these companies are actually rendering as a service to varied number of clients. So they are actually rendering things as a service. The same way also cloud computing works in, wherein these vendors like Amazon, or let it be Google, or Microsoft Azure, the high top three vendors who are actually ruling this cloud computing world, they are all providing this as a service, and they are having their own products. And next important thing is we need to know is, we are using these things in a form of a shared resource model. So the resources are being shared by different people and used in a differential way, and we are actually having it accessible via software and information. Another important thing is, like, we are trying to have these computers and other devices as a utility in the sense, like, they are all integrated in such a way, like it can be used from from anywhere, and it is easily accessible. So how you see, like, these electric substations are all existing, they have something called as a grid structure, wherein each and everything are there, and the power is getting distributed from there. The same way only these computing networks, like all these what to say, your servers which are actually kept, like how you have in your server rooms which is there in your colleges. The same way, when these vendors are actually having these servers, they manage it over a large scale, which you'll come to know how it is on a small picture base on upcoming slides. And the most important thing, it is not towards the end, but this is actually the beginning, and it can be accessible only via a network. So internet is a prime requirement for accessing cloud computing resources. Without that, you cannot have accessible to it. So on a just this the separation of all these things I have just concluded with a small kind of a definition which they have explained it. So considering it, we call cloud computing to be a model kind of a structure, and we have all the shared resources accessible. So like there can be networks, there are going to be servers, there are going to be storages, there are going to be applications, and there are going to be services. So these are the varied levels of services which is being provided to us, and they can be rapidly provisioned and released. So this is a very important thing. So based on your on demand requirement, whenever you want it, you can just provision it, and whenever you do not need it, you can just release it back to them, and you're going to pay for how much you're going to use it, the time period which you're going to use it. So that is how it is being maintained. Okay, so I have just given some definition about cloud computing. So you may think, okay, so there are various terminologies with respect to cloud computing which we need to know, but how they can be interrelated and be used. So this image just shows in such a way like, okay, some various terminologies used with cloud and how we are going to relate it and use it here. So we'll come across those terminologies, like not all, but few, so that you can have a better understanding of what cloud is all about and how it is actually working in. So a small gist about the history of cloud. So I have not taken from the beginning of the history. Like I told you, it started in 1960s itself. But from the 21st century, I just wanted to show, because that was the period wherein there was a rapid development in cloud computing. So starting in 2001, IBM pitched in to give software as a service through cloud. And then when came our giant Amazon Web Services, so they pitched into 2002, and then Google also came into picture, wherein they launched few services like Google Docs and other stuffs. And then Salesforce, they were also a kind of a vendor, but they were the first who were to launch the services called as platform as a service. So I'll just give these terminologies like software as a service, platform, what they are all about in upcoming, but just try to understand like, okay, these are the people who actually patched up the first level of development there, and then it came with the other vendors. And then again Google came in, then Microsoft also came into picture in 2009 and 2010. Salesforce, they have something called as database.com. They try to develop this for developers especially. Okay, so why we wanted to move to cloud? Why can't we use the existing resources wherein we can just buy the servers, keep it, and use it for our own purpose? Why do we really wanted to go for this cloud technology? So one primary and major important factor which you should know about is the cost cutting, which is actually happening in each and every part of the world. So it is not only with this cloud resources also, but in every resources which you're trying to use it nowadays, we are actually meant much about the cost which we actually spent over it. So cost cutting has become a major factor, and this cloud has actually helped us over the usage of hardwares also with respect to cost cutting. So how they are actually done? So we are not going to own any software or a hardware, but we just try to use it only. Then we are just going to not pay any fixed amount for that, but we are going to pay a kind of a subscription fee, or based on how much you're going to utilize it. There is no way you wanted to have some maintenance kind of charges, or you need to maintain yourself. It is all taken care by them. And as I told you, a good example about a house, so we are not worried about like how it is and everything. We are just going to take care and just use it alone. So how about it is being cared, it is all being taken care by the vendor itself. So there is not going to be any depreciation of software or hardware in this case. Of course, the important factor is nowadays we are not stagnated to any one of the place. So it is like we keep moving from different places to one another. And even whatever we, even for buying small things also, we just buy things today in one market, and tomorrow we go to the other market. So such kind of a mind relation we have nowadays. So the same way, just think about using these resources also. If in one scenario you think like, okay, I'm not finding this vendor to be good, I wanted to move. So when we are having it with cloud, it is relatively high easy to move resources between different clouds also. Okay, so I was just telling you about something called as server rooms. So server rooms are something wherein we actually maintain all these servers in bunches. So just a small picture, like a 0.1% of big data center is how it looks like. So this is how it's going to look like. This is just a small portion of one of the big data centers which is being maintained by Amazon and Google. So this is how they actually maintain in kinds of racks. They maintain these servers connected by networks, and they have storages also been in place. And here is how it is being distributed and used by different users based on their requirement. So this is how it looks like. Okay, so I've told you what is cloud. So there should be some way like we need to understand like, okay, what are the features we have in cloud computing, so that we could know, okay, so these are the thing a good part of cloud is all about, and we can, when we try to pitch in inside this. So some here I have just mentioned here is like we have uh, can easily free up the internal resources. We have, of course, the low capital expenditure. We are not going to have a much capital expenses over this area. It is going to be highly reliable, scalable, and sustainable. So these three are actually an important terminologies which we need to know. I'll just brief it when we go ahead. It is actually highly automated. It is a good utility based, and it is highly agile, device and location independent. So we are not going to worry about where your device is going to be and which location specific. I mean, like we will be able to choose which region we want to use the servers, but we could not know like in that region where it is actually located and from where we are using it. So that is kind of the independence which we actually see here. Of course, when you're trying to provide a service, there should be a support provided for them. So all cloud vendors, they provide 24/7 support for these things. And of course, we are going to pay only for what you're going to use it. Okay, so I just briefed all these features a little bit. So I'll not go much depth into these things. I'll just have a wrap up of all these things over a top layer. So freeing up internal resources, what I mean is like we are not going to have any centralized kind of servers. No network equipment is going to take into picture. We are not going to have any storage devices also. There's no kind of maintenance staffs involved in this. Of course, no office space. We are not going to have any physical resources. We are just going to access it via internet. Whatever you need is just an internet, a kind of a laptop or a desktop to access your softwares and get in touch with these resources. So that is what is the requirement. Capital expenses, yes, you're going to have a highly low capital expenses because you're not going to have any investment over the servers, the power, the cooling cost, physical infrastructure. You're not going to maintain anything. So actually we have these so many startup companies which are now coming up. So this thing, they are, it is not a good thing like they wanted to have an investment in building such kind of server rooms and everything, because even just think about the colleges which are actually existing nowadays. Like if there is a new college coming up, setting up a server room for them, giving expenses were all a kind of a big cost involved for them. But nowadays it is like they started moving into cloud, wherein they can easily use the resources. They need not want to invest much at the beginning level itself. So startup companies, this was a big encouragement for them, this cloud cost model. Yes, I told you some terminologies: reliability, scalable, and sustainability. So what is reliable? So we are not going to have much reliability over the physical and the underground resources. Like for example, the power, the cooling system, the fire suppression levels, and the servers and storage. We are not going to have high reliability on them. So that is what I told you, like we are not having much reliable on the physical resources, but we are just going to rely on how we are going to access these resources, of course. And then scalability. So just think, when you're going to have your when you try to buy some hard disk, for example, you're buying some 500 GB hard disk. So do you think like it can be scalable more than 500 GB when you're trying to use it? Of course not possible. Maybe you can use the less amount of resource also, but still you have been given a cost for 500 GB of hard disk. But in case of cloud computing, it is not going to be like that. Even a 1 MB of resource can be used, and you're going to be paying for that alone. And you can even go for 1,000 petabyte of data on a just like that on demand kind of thing at the second, so that you can easily use that space also. So that high rapid scaling is available with cloud computing. And of course we need to know wherein now we are actually have a technology driven world, wherein we have the disadvantages with respect to pollution also. So this is actually a sustainable model which we could actually tell you. Because just think, like if you are going to have a two-wheeler, and in a two-wheeler maybe like two people can go. So just think, if there are 100 people to go, you are actually taking 50 two-wheelers. And just think of the pollution it is going to create. And when you're trying to use some kind of a bigger transport, like you're going to use two buses, so how the pollution is going to reduce. So that is how the differentiate between this private and public transport came into picture in reducing the pollution. And even now in the kind of a developed situation, we are trying to move it toward towards a public kind of accessibility, so that because we need to take care of this pollution creating a big problem, and we need to reduce it. So with respect to cloud also, when we are trying to set up these server rooms and everything, like we have these cooling systems being coming into picture and emissioning so much amount of gases outside. So this kind of a big kind of data centers which is being set by these vendors, they actually try to maintain it in such a way like this cannot be completely eliminated, but still they can reduce the usage of these. So we need to think about this way also, like not only on a technological perspective but on environmental aspect also. Next, automation. So everything nowadays in the world is actually automated only. See, when you actually, like we were all in colleges when we actually started, so we had these attendance registers maintained and everything, we come and sign in, and now you see like we just come in, have the thumbprint, it is all biometric systems, and now it has changed. So things are like such a way like these are automated in that way. So when you think in that aspect, so we see like everything is highly automated. So even when using these hardware things, we are actually having this automation in picture also. So we actually use these hardware resources, and when we are trying to have a repetitive model, then in such cases we can think about how these automation can play in picture so that we can reduce that workload. So automation basically is to reduce the repetitive kind of workloads. So that also comes into picture here. Then we are going to see about utility based. So as I told you, we are not known about the physical resource at the back end which is being used. What we do is like we are just having the what to say, kind of a software at the front end wherein we access these resources. So it is a kind of a utility model is what we tell here. So utility, I mean like it is actually invisible. As I told you here, it is actually invisible, and it is transparent also. Transparent in the sense like, okay, whatever resource you're using, you can easily view it at any time, and it is always available also. Easy and agile development. So agile, I think everyone would have come across these terminologies, agile development. So even here, agile development comes into picture wherein there needs to be a high sync between your accounts, like okay, how much you're being using it, everything is actually highly synchronized at every period of time. So it is like, for example, like I wanted to know by the end of the day how much is the cost I have been for you today, they are easily updating it for you. So that much is how this agile process, not only in software but also in cloud, is taking place. As I told you, device and location independent. So we will not be sure like which is the device which we are specifically using, but we'll know like from this region only we are able to access the resources. So that is what it means, like location and device independence. Of course, whenever you're going to provide any service, you need to provide a support for them. Then only we can actually exist in this real-time world. So they are able to provide 24/7 support, and these cloud vendors are actually able to maintain a 99.999% uptime over this competitive market, because that is a much required thing. Even a small downtime is actually going to ruin so many businesses. Just think how these stock markets are working. If there is a small crash, just see like how much points it is going down and up. So that is how important it is, because it needs to be available all the time, because it is being highly critical too. And as I told, we are actually having a pay kind of model, like pay as you use model. So even in pay use model, we have the different way how it is being utilized, like a kind of a subscription based. As I told you, like we can actually have a model wherein we can use a subscription model, pay per reservation and pay per use. So it is similar to how in a real-time scenario we are using it. For example, when you're trying to rent a house, we can rent it in a way like we can actually have a bulk amount paid, called as something called as leasing, long-time leasing, which we take in. So we pay a bulk amount for a house and we stay for it. We are not going to pay the rent, and once we are leaving, we just get back the amount, something like that, and just pay a minimal amount only. So that is kind of a subscription based and pay per reservation models. And pay per use model is like how much ever you're going to use it, just pay for it, like how electricity bills are paid, and your monthly rent payment. So all these things comes under this things. So this is how we consider this subscription based and pay per use model. So we can make it over a quarterly or a monthly basis, and even on a yearly basis also. Okay, next is comes this ownership. So we are not worried about the ownership of the equipments being used at the back end. So our total cost of ownership is actually getting reduced. So ownership in the sense like we are not going to have any, we are going to have not going to have much capital expenses in this area. So we actually have some costs being paid based on the utilization of resources, and it will be detailed with us like how much we are using and everything by the cloud vendor. Okay, so all this time we have seen a good lesson about the features of cloud. So as we discussed on the features, of course, we are coming across all the advantages across this cloud computing. So what are the expenses and how it is being maintained? We are not, how the software upgrades are actually happening. They are able to maintain on a high level of upgradations, and storage capacity being unlimited based on the usage. You can how much ever use it. Compute cost is going to be lower, and of course there should be some disadvantages also, which we need to take care into consideration and try to overcome these features. So a constant internal connection is required, so this cannot be totally taken out, but of course we need to maintain a proper internal connection with a good speed to access the resources. That is important. And then there can be chances like store data can be lost, but it is not that much because they are able to give us a durable kind of thing around 99 point, I think 99 about, after dot it is about 99s they are able to provide. So 99 point that much percentage durable they are going to able to provide with the storage data. But still, as a vendor in a competitive market, they could not completely give 100% reliable. And then with respect to data security, we need to take care about it, because see, we are using a kind of a shared model, so there are some thing which we also need to take care with respect to security and other stuffs. Okay, so how, why we need to go to cloud? This is also, this picture also give us a good example like why we wanted to take this into picture. So just think about the traditional hosting system, wherein we are connected to a single server and your application is inside that server. So when there is a problem in that server or something, it goes down, there is some power problem or some issue is happening, hardware or some problem is happening, then your application is completely lost. It is not being broadcasted anywhere. But with respect to cloud, they're able to provide us featured way in such a way like when there is any problem with any of the servers also, we are able to readily available the application with different other servers and project it outside. So that is a kind of a highly available system is what cloud is being able to provide that. And it is based on our requirement also. So we should be sure like, okay, do you want it to have a highly available system? If so, then what is the thing you require? So we need to decide that when we are trying to choose the vendor to use your resources. Okay, so what are the good benefits we have out of using this cloud? So these terminologies are already discussed, but still I'm just trying to wrap up these things, because we have some good productivity from anywhere of the system. So that is a big good benefit of cloud. And storage, data storage, it is not, it is kind of an offsite data. So offsite data storage in the sense like we are having it somewhere else, the storage, it is not under our control. We are not going to have any IT maintenance cost involved in this, of course. And a really important feature, this disaster assistance. So DR is a kind of an important feature, because nowadays we need to have every applications on a complete uptime. We cannot depend on, like for example, you just tell like, okay, this area is under disaster, so your application is completely going down. Maybe for a smaller amount of time people can accept, but on a larger point of time they won't accept it, like very critical things and all. So in that case, cloud is able to provide a good disaster assistance, wherein they are able to, as I showed you in the last picture, like they have different servers interconnected. So that will be on different regions, so that if any of the disaster occur in one of the regions, maybe it could be available from some other region also. So that is how they are able to provide disaster assistance. Of course, when there is a disaster assistance, it will be always up. Ownership, where it is going to be highly low, and upgradation is going to be very easy. Okay, so we have almost got some idea, better idea about what cloud is about, features, and what are the different ways, benefits, and everything. So how they are able to provide you, how cloud is being provided to us, which is the way we need to choose it and use based on our requirements. So there should be an interrelation, like what is your requirement and how that can be availed from your cloud service or your cloud vendors. So that decision interrelation should is actually being defined through these service models. So there are various service models available. So the main things I have listed here are the top three. So we have many more services also. Like the first three are infrastructure as a service, platform, and software as a service. I remember like these technologies came across in the beginning of the slide also. So to understand these terminologies, I have just inserted one small examples, a real-time example, so that you can easily compare between this computing services with the real-time examples. So infrastructure as a service is something like when you're trying to build your own house is something infrastructure as a service. Another example is also your own college server rooms which you're maintaining. So servers is completely being owned by you and you're going to use it. So that is an infrastructure as a service. Next is platform as a service. So in platform as a service, it is something like when you're trying to rent a house. So all the building structures are all remaining going to remain the same. You're just going to internally you set up all your furnitures or whatever it is, and you're going to live inside. So that is how platform as a service comes into picture. And when it is software as a service, it is a kind of a lodge or a hotel which you're trying to use it. So you're not going to touch any of the resources which is being set here. You're just going to use it, and once you're done, you're just going to come out of it. So these are just kind of a real-time examples I just wanted to show you. Okay, so on a IT perspective, so I just wanted to define these different ways of services provided. So one example, I just a clear way to define things on what all exist in cloud. So from the bottom, like first thing is you require a networking to interconnect between devices, and you need storage for your data, and servers are for your computing. And over that we have something called as virtualization. So what is virtualization? I'll just let you know in some time. And then over that we have the operating system. Then above that we have the middleware kind of things and your runtimes, and finally your application sits on top of it. So on-premise is something which is completely managed by you alone. So your server rooms, so you only bring up the you purchase all your servers, you come and set it up in your office, I mean like in your college premises, and you connect all your networks and maintain the storage and servers. So everything is being completely maintained by you. So that is something termed as on-premise. And when it's going to be infrastructure as a service, so in infrastructure layer, the bottommost layer, like your hardware kind of things are all maintained by the vendor completely, like the networking, storage, servers, and virtualization. And over the top of that, your operating system, your middleware, your runtime, and your applications are all taken care by yourself. So here comes your shared resource model. So whatever resources is being shared by you, you need to take care of it. Whatever is being managed by the vendor, they will take care of it, which you need not worry. So that is a kind of a mutual agreement in using the services being provided. And when it comes to platform as a service, we have this operating system, and the runtime is also being set by them, and it is being taken care by them. So whatever is in your side is you're going to run your applications alone over that. So that is only going to be your perspective. So a good example I would like to quote here is for infrastructure as a service. We have services like you need to choose your own operating systems, and when it comes to platform, you're choosing your own applications. So software as a service, it is completely like all the layers are being taken care by the vendor. You're just going to use your software. So one simple comparative example I could give here is a simple thing is your laptop. So when you're trying to, you go to your shop, I mean like your electronic shop, you're going to buy a laptop. So you will actually define like, okay, what are the set of features or specifications you need for a laptop, right? So the same way, something like we build up the requirements, okay, and when we want to get it as a service, what are all the requirements we need is all being decided at the first time. So once you go, you choose your vendor, for example, Dell, HP, or whatever it is, and you buy the laptop based on your specification. So now it is like your laptop is just a hardware, nothing is installed and nothing is there. So that is now kind of an infrastructure which is being given to you. So this is just on a small level. I'm just trying to correlate and tell you it is not on a cloud perspective. Your laptop could not be a cloud perspective, but this is how on a real time it is being maintained. So when you're going to take your laptop, it is completely empty at the first level. So after you buy the laptop, then the vendor comes and asks you what kind of operating system you wanted to install, and based on that, he's installing it and providing it to you. So now the operating system is also installed, and after that, when you try to log in and open inside, you install your own softwares and you start using it. So this is how the layer by layer approach comes. So your laptop is going to be your infrastructure over operating system, which you're going to set it up. That platform is going to be a platform as a service, and over that, whatever software you install over it, that comes under software as a service model. So these are some small examples I would like to list here. So when it's going to be a software as a service, like for example, all your package software, antivirus softwares, everything comes under these software as a service model. There are also various collaboration software wherein different people are trying to utilize over a collaborative kind of a structure. Then platform as a service, wherein we have these Google kind of Google engines, wherein a bottom layer of operating system is being provided to you, and over that, whatever software you wanted to install, you can take care of it. So that is a kind of a platform as a service model. And infrastructure, it's completely like your hardware is being owned by them. Over that, what things of softwares or whatever you wanted, it is being chosen by you and you are going to use it. Okay, so some examples, of course, whenever you try to learn something, you should have some good examples to correlate it and understand it on a better way. So examples here are something like software as a service. We have your famous Facebook, WhatsApp, all these things are kind of software as a service model. On platform as a service, we have Google App Engine, Windows, Azure. We have a platform service they are also providing. And force.com is one of also a vendor. They also provide in a kind of a platform as a service model. And then coming to the bottom, infrastructure as a layer, Amazon Web Services, they are a very good example of infrastructure layer provisioning. So over that, every customization and everything is being taken care by you. So that is a kind of a freedom being provided on infrastructure as a service. Okay, so now we have learned like, okay, what kind of or service model can we take? But when we are trying to put your application inside, we need to decide like what kind of deployment model in the sense like what kind of a cloud I need to choose, because based on the security level and other important information about the application and your requirements, we need to make sure like what kind of a cloud we also choose in perspective. So some terminologies I have given here, like, okay, what are the type of cloud ecosystem, how ownership is there, what is the size of the resources, access to resources. So based on these things, we need to decide on what kind of a deployment model we are going to have here. So in deployment models, we actually have different levels called as public cloud, private cloud, community, and hybrid. So these terms itself gives us a basic understanding, okay, what it really means. So, and that is what it means. I'll give it in an elaborate way. So when we come to a public cloud, it is like a kind of resources being shared in a public space. So we need to take care about our resources on a very much high level. So but when we are going for a public cloud, we have a cost effective model. And also it is like public cloud are, it is not like, it is not completely insecure, but it is secure to some extent. So it is a decision maker, like when we are going to try to host our application, whether it can be on a public or a private, with respect to security and other stuffs, we need to confirm it. So some examples of public cloud is Amazon, SoftLayer, Google also there, Azure is also there, Alert Logic, Security as Service. These are all kind of a public cloud service being provided. So what are the advantages of it? Of course, it is very cost effective. It is going to save your time much. There is a good automated redundancy actually happening at the back end. There is going to be an easy recovery model, a kind of a paper usage model also. So we are not going to have, with respect to cost, we are actually having a good saving with respect to public cloud. And then disadvantage, if you see, we do not have much management control over it, because we are trying to use the third party resources. Of course, that is what cloud is all about, but still some may consider like they wanted to have this hardware also under control. If they're not worried about the cost, then it is their own choice. and it requires internet. It is not a big disadvantage, but of course, people are finding that also as a disadvantage at the beginning level. But nowadays, it is slowly getting removed from a disadvantage perspective, because nowadays everything requires internet for usage of resources. That is how it has turned the world. Okay, private cloud. Private cloud is something like you completely own your complete service. It is not being owned by anyone else. Like for example, it is being by between only your vendor as well as yourself. The servers and everything is being completely owned by you, and you can use only you can use it. So that is how private cloud is all about. So when you're going to own something and use it, of course, we need to have some disadvantages as well as advantages. So advantages, of course, it is very highly secure because you're completely owning everything. So how much ever ownership we take in, that much our security is there. But still, even with a reduced number of ownership, we are able to map security in a better way also. Then data transfer is very high, dynamic to demand. That is, it has been easily, it can be scaled on a demand basis also. Of course, on the cons, expensive is very high, very investment is huge, and then there requires some maintenance also. Community cloud. So this is something like how we had a system wherein individual houses were built or in the last generation, and nowadays we have come up with this flat systems. So that is how this cloud is also taking itself from the one level to the next level. Like a community perspective is something like there is some good understanding between a small amount of people, a small amount of community, in sharing the resources and being using over this private cloud itself. So this is a good advantage wherein when there is a good understanding between different organizations among themselves, and they can use a kind of servers maintained and divide and use among themselves, so that there is not going to be any problem with respect to security or information sharing. And this is also used on a high amount of period, I mean usage nowadays, because at the beginning this public and private was in picture, and that has made to the next level of development with this community. And one more thing is hybrid cloud. So before hybrid, I just want to tell the pros and cons of this one. So it is of course less expensive than private cloud because it is being used by different amount of organizations now. And security is good than public cloud. So it is all a comparative study here. Investment is bit high than compared to public cloud. So as I told you, the next level is hybrid cloud. So hybrid cloud is something like, for example, when you try to have an application designed in such a way, like you have your front end and your back end application. So usually with front end applications, your applications, we do not mind much security about the application, because nowadays it is important to have it over a secured pathway to I mean like to host your application. So that is the only thing, and that can be done on a public cloud itself. But with respect to backend, like your database and your data, that has to be highly protected. And there comes an involvement of this hybrid cloud structure, wherein you can choose your private cloud for secure things and public cloud for your less secure things, and integrate between them and create a hybrid cloud structure. So this is also a possibility which can happen. So what are the pros and cons? Of course, the cost is a bit low and easy integration with technologies. Yes, integration is a major picture here, wherein we are going to integrate between public and private cloud here. And then it is highly scalable also. And security wise, it is good, easy to switch between clouds. So when you are going to host everything in cloud, so switching between clouds is also an easy way to choose. A disadvantage, like with respect to dependencies, we have some dependencies here. Then SLA, we need to take care about it. Networking is a bit complex because we are trying to build a little bit complex structure where integrating your private and your public cloud. So a complex networking is involved, but you can overcome it when you try to understand and design the architecture in a proper and defined way. That is actually good. Okay, so all these times we learned about cloud computing. So when you learned about the services, we came across something called as virtualization. So what is this virtualization all about? So we need to have some small picture on that. So virtualization is nothing but a kind of a layer in between your hardware resources sitting at the bottom, over which your software is accessing all these resources. We need to build a layer kind of a structure to analyze and design in such a way like your hardware resources are being efficiently and properly utilized over software. So that is the layer called as a virtualization layer. So it's characteristics involving like how you have your applications designed. We have something called as oops concept. So we design based our coding and everything based on your object oriented systems. So the same way that is some characteristics with respect to virtualization also. So they take care about how the resources needs to be partitioned, how the isolation needs to happen, how it needs to be encapsulated, how the OS version rollback and restore needs to take place, how the abstraction level, that is a direct access to hardware, is how it needs to take care, and how it is highly portable also, taking backups and enabling restoration. So these are all kind of oops concept only, which is also a part of virtualization, which we need to understand. So we there is some correlation between when you are trying to use your hardware as a software also, you need to take care of all these important characteristics in virtualization perspective. So a small picture which is giving you a simple idea about how this is actually set up. So at the bottom, if you see here, we have something, all these hardwares are present in the bottommost layer. So these hardwares are just the servers which you actually saw in, and these top layers are actually the users who are actually trying to use the resources. So in between that, there is a layer called as a hypervisor in picture. So this hypervisor takes care of how these underground resources are being I mean, like, it takes care of about the characteristics and define for all the guest missions at the top, like all your users how they wanted. It is being taken care at the top level end. So this is how it is divided. So what is a hypervisor? It is a kind of a software or a firmware you can also tell to run all the virtual machine. A host mission, that is on the top. These are all kind of a physical missions on which the hypervisor runs. And the guest mission is actually the VMs, which is actually having we get it to access the resources. Access is like a small kind of your virtual an existing mission on a virtual form, which we are getting in. So these are different kinds of hypervisors actually available. So it is not important to know much depth about hypervisor until and unless you are going to work on a cloud hardware perspective. You need to understand these hypervising layers. But I just gave a note here to just know that, okay, so there is something called as hypervisor and how they are actually used and how they have created as of now. So they have divided called as a type 1 and type 2 hypervisor. So these pictures can easily differentiate how these type 1 and type 2 hypervisor play in picture. So there is a hardware and a hypervisor layer, and over which there are different operating systems, and over an operating system itself there are different applications. So this design is kind of a type 1 hypervisor. And in type 2 hypervisor, if you see, you have your hardwares at the bottom and a host operating system. Operating system is first placed on the bottom, over which only your hypervisors are placed. So there is a differentiation wherein this operating system and your hypervisor are swapping between each other and giving a different variation on the topmost layer. So usually they tell like type 1 hypervisor provides better performance than the type 2 because it takes care from the bottommost layer, because here it is like an operating system is involved in between. See, it is the same way like how you have your infrastructure as a service and then how you have your platform as a service. So how much ever security, I mean, like usage is being reduced, that much level of performance and your ownership all reduced. So that is how this is being also analyzed, and just a small comment they have provided. So what is the pros and cons? It saves times and money. There is a complete single control, and it is highly easy to manage and secure. So cons is like performance is little bit degraded, but it is not that much degraded when you consider a large amount of huge servers maintained. But when we consider a small amount, setting up all these layers and everything actually involve much cost, and there are chances to get degraded. It is a bit complex in nature, but as kind of users, we need not worry about these things because it will be taken care by the vendors completely. Okay, so we learned something called as virtualization and cloud computing. A simple vice versa kind of understanding between what are the difference in these things. So virtualization, it is a kind of a software which divides your physical infrastructure over your dedicated resources, like all your multiple resources which is available. But with respect to cloud, it is mainly based on your virtualization. So it is almost interrelated, but still there is some way like you need to know a vice versa thing also. So virtualization, you need to know, like, it is mainly associated with hardware and your physical, but cloud is involved completely on how we are going to manipulate it and provide it as a service. Virtualization is actually the foundational. Yes, it is the bottommost layer of your cloud computing. And when it comes to cloud, it is almost the top layer, which is being provided as a service. Okay, so all the time we have now had concepts kind of virtual technologies, that is cloud. So how secure it is? Security is also an important perspective which we need to take care and we need to understand also. So with respect to cloud security, if we see, we need to know like whether it can be achieved through all the control based technologies. So whenever we are trying to choose some technologies and choose some services being used by cloud, we need to have some good understanding about them and choose it in a right way when it is going to be part of a business. So when we are trying to analyze, so a better analysis should always be made before trying to make it live and take it to a high level of business. So a low level of understanding is actually very important to know it, and you should actually have a strict regulatory compliance rules should be adhered when you're trying to use it. See, whenever you're trying to have a normal kind of, see for example in real time itself, if you see, when you're trying to buy some resources, not resources, that example, you're going to buy some things, we try to choose the things such that it is having a good regulatory compliance also. See, we nowadays have these ISO certification, even in colleges now we have this NBA, NAC, everything. So that is all a kind of a good ranking which provides that okay, you are the best. So the same way, even for cloud computing, these resources is actually adhere to some certain compliance rules to tell them that they are actually the best. So with respect to cloud security, the points we should actually know and understand is important is like, for example, so we need to have a review on the security architecture and policies. So whatever, so here it is a kind of an SLA understanding. So when you're trying to buy a house, we actually have some agreements written and everything, and there is an understanding between both the parties, like okay, this is a way it has been provided to you and you can securely take it and use your thing. So the same way, when we design an architecture for cloud, we need to be known in such a way like okay, what are all the background resources you're going to use it and how efficient it is, so that it is going to give you a better structure. Then you need to know about how the governance issues are with respect to the cloud levels, the data presentation and protection, what are the protection techniques they are going to provide it, location of your data. So location of your data is actually important. And then separation of data between your application and your management tools, so how that separation is going to occur, your data portability, patch management is also one of the important features because you need to have it updated, because when you're trying to use your infrastructure as a service layer, patch and all needs to be taken care by you only, because you're going to choose your operating system, so you need to have it updated always. Then all your firewalls, so firewalls is actually very very important with respect to network, because that is going to make your application very secure. And how we are going to access these resources and how we are going to distribute this access resource between different people to use it, it all needs to be decided by you when you're trying to choose the cloud vendors and how you're going to use it. Okay, so we told like there is a good easy transmission between different clouds, but still a few challenges I just wanted to gist here based on my work experience and from an organization experience which I actually faced as a challenge. And of course we overcame these challenges also, because nothing is something like which cannot be overcome. So few overcomes are like organization issues, like organization will have some certain standards which actually needs to be mapped with the cloud standards. So that is a kind of an issue which needs to be properly designed. Then defining the strategies, what are the different strategies you need to maintain during different scenarios. For example, I told you like disaster scenarios or some other situations also, like if the data is full in your usage, how you are going to extend it and buy some extra resource, how we are going to maintain it. So these are kind of strategies which you need to design it. So defining what resources you wanted to use and ensuring that it is optimized and used, it is not going to make your cost more also. See, actually cloud is completely a kind of a business level only, even though they are going to provide it the best as a service, but until and unless it is completely going to be a business layer, you need to take care of resources which is being taken from them. so that the cost is being properly utilized, because they are not going to come each and every time and tell like, okay, you have owned these resource but you're not completely using it, so if you want we can return. They will never worry about it. They will just charge of how much ever resources you're going to you have got it, whether you're using it or not. So you should make sure you're having it optimized and used. So for all these things, we need a continuous monitoring to be done. And of course, you need to have the cost managed properly. So measures to manage these services. So what are the measures we need to take care? So we need to take care about the performance monitoring. The monitoring of the performance should be there. Standardization should always be maintained. Of course, we need to remove all the old data which is not in picture or which is not in use. Any new issues coming, we should be able to forecast it, and testing all your services properly. Repeated services, repeatable services, like as I told you, like, or all your automation and comes into picture, how we are going to do it. Responses to how the failure actually occurs. If there is any unwanted failures and everything, how you are going to respond it on a quick basis, and then how the customer experience is maintained on a better way. So all these factors should be taken into consideration when you're going on a larger level only. So at the smaller level, when you try to build applications and use it, maybe these terms need to be known, but it needs not be implemented on a complete picture, because at that time we will not worry about security and all. But on an organization perspective, on a bigger levels, all these things needs to be taken into consideration. For example, even when you're trying to have in your own college a big cloud setup needs to be done, wherein you need to access resources, make a cloud setup for all your students kind of usages, and you're trying to host your applications, your college applications in cloud also. So all these factors you need to take care into consideration in a very important way. So it is a kind of an architect design, like how your house is being designed by an architect. Even this cloud design has been done by an architect also. So based on my experience over those things only, I just did some points here. Okay, so infrastructure as a service is actually a good level of service selection when you need to have your machine storage and network as your baselining, over which you can choose your operating system or your middleware and your softwares, whichever you wanted to use it. So when you're going to have this infrastructure bottom layer, so different cloud vendors are being providing this infrastructure as a service in different ways. So with respect to Amazon, they call it as instances. Your virtual machines or your infrastructure services called as instances, which they tell here. So that they have actually divided based on the utilization, like whether it is a normal utilized, whether you need a optimize it. I mean, like you need a high compute power or a memory power or a storage. See, for example, if you're going to use a gaming software, so gaming require a high memory and a high compute power. So when you're going to have something called as a storage, high storage like SQL kind of thing, your storage is actually, then you go for a storage optimized kind of systems. It is kind of some normal POC kind of setup, your POC setups you're going to make, or a small kind of testing you need to make. Such kind of thing, this micro instances will help. So these are all on a different cost levels. I mean, like costing levels, and based on your need also. So it is not like, see, for example, when you try to use create a small POC only, but you go for a high memory and compute optimized, this is not a good right choice. You need to make it. So based on your requirement, you need to map the proper resources and utilize it. Okay, so I have almost come to an end on my theoretical way, like on my explanation. So this is my contact details. So if there is any help you require, you can just contact me. So now I would like to give you some small demo in from AWS. So I'll just open my Amazon Web Service console. So I have already created an account and I'm using it extensively. So if you want it, it is just by a click. You need to sign up you need to create your login, sign up into it. And a debit card is actually required with respect to Amazon, and with other vendors you require a credit card. So we actually have a free tier kind of usage, like a free usage is there, like up till 1 year. But in order to have a proper utilization of a free tier is why these debit and credit cards are attached at the back end. There is a transparency with cost also, so you need not worry like your amount will be going off or something like that. So you have a transparency in the cost also. So if you are going to exceed the free tier usage, of course you will be charged. Until and unless you will not be charged. So you can create an account and then use the resources from the bottom level. So let me sign into this Amazon Web Services. So this is actually a kind of as I told you, that top layer of software which is actually going to have an interaction with the back hardware. It is not actually the virtualization software. This is actually the software wherein you're going to access all the resources. So all your resources are being provided in the form of a services. So there are like kind of so many services being provided by each and every vendor. So I think here around 50 to 60 services are being provided by Amazon. So it's like before, like around 5 years back when I stepped into this cloud, and when Amazon was in picture, I started working with Amazon. It was like some 20 to 25 services I think would have come across a max with AWS. And after that, like nowadays, they are like every month they are able to bring out some new services based on the customer's needs and based on the customer's usage. Everything is being analyzed and different services are being brought with the recent technologies. So as of demo, I'll be showing about this EC2, which is actually an infrastructure service, on how we are going to create a virtual machine, and just show you like how can we host a small application, like a sample application, and access it outside, because that is actually a good baseline to start with and do and work with and play with cloud. So here you have all these kind of services, and here is about all your account details, like your account, your organization, your billing dashboard we have. So in billing dashboard, you'll know how much is the billing being done, what are the costs based on the resources being utilized, everything. And this is actually a very important part, like what are all the regions wherein are having their data centers, and from which data center you want to choose the resources and use it. So in India, I think we have it in Mumbai only. So there are various other locations wherein we have the resources. So why need we need to care about these regions is because, see, there is a thing called as in networks you would have learned something called as network latency. So network latency is all about when you're trying to have an application which is being hosted in United States and you're trying to access it here. It will actually have some network latency because there is a network from there to here. It needs to communicate and your application needs to come here. So that is where this region comes into picture. So whenever you wanted to host an application, maybe for a POC level it is not required, but on a higher level, if you wanted to do it, whichever is the nearest location, you need to choose it, because that will help you to avoid these network latencies. There are even so much technologies which have come up over that, like caching of your resources and everything, but still this is actually the baseline which you need to choose, because there is different cost involved, because each region have their own cost based on the resources being available there and when it was built, and everything is involved there. So as of now, I'm going to use by default this North Virginia only. And I told you that 24-hour support is there. You can have your support tickets raised, and if you have any queries, you can ask them. They will be replying it. So in services, if you see, like we have for compute, they have for storage, they have different kinds like S3, your normal kind of, I mean, like your hard disk or something. We have something called as storage. EBS kind of block storage kind of. So you would have learned in storage also, like we have something called as block storage, file storage, and everything. So EFS is kind of a file service storage. So many things are coming up. Even backup they have created as a service, because you need not to need to create a separate software or care about the backup. You need to set up some small kind of a jobs alone so that it automatically takes backup. And even RDS, I mean, like database, they have customized and provided various RDS services like relational database. And when you go for NoSQL kind of database, they have DynamoDB and other stuffs. And data warehouse kind of technologies, they have something called as Redshift. So many things, like when we come with respect to networking also. So with respect to networking also, we can actually take care about, okay, sorry. Okay, sorry, I just forgot to share my screen, so it just missed up. So this is actually the AWS console. When you try to log in, you can just log in, and let me start with these tabs. So these are the services which has actually been listed as part of AWS. And as I told you, the accounting is also available here, and the regions which I actually listed is part here. So I don't think nothing would have been missed in between. So in services, as I told you, compute is there. Storage, with respect to different storages, we can choose different databases. You can also choose. And then with respect to networking, because networking plays a very important role with respect to security. So designing in the network is actually a very important part. And VPC is the baselining for your networking. And there are developer tools. So of course, if you're going to be a good developer, there are various developer tools which is actually available, whether for your code. For robotics they have, and there is also various tools for management, for governance perspective, from an organization perspective. With security, we have something called as identity and access management, like how you're going to provide different identities to different people who are going to use your cloud resources. Everything is there. Few softwares are also there. Key management services, different keys you can provide with respect to security. And then you would have learned come across these dockers and container technology. So even there they have provided various services here. With respect to mobile also, they have provided various mobile services available there. So many things, there are so many things to explore. So each and everything I cannot go into much depth. Even here I as far as my working is concerned, I know about some 30 to 40% of the services in a better level. So many are actually new to me because I did not have a chance to work on those things. So based on our requirement only, we need to choose and use the resources in a better way. So as of now, as I told you, I'll just explain you about one service, EC2. So here I'm trying to create a new resource. So instances, this is a kind of a normal virtual machine. So as I told you, this is actually an infrastructure. Why I told infrastructure is, when I'm trying to create it, you will come to know like we are the one who are going to choose what operating system is involved in it. So once your operating system is choose, we are actually built in with a kind of a normal laptop kind of a setup, which has been virtually accessed via IPs. So for an easy demo, I'll just choose Windows. So Windows, just choosing it. Okay, so I have to you, if you would have remembered, I have told you like the different instance type which I have listed, like what to say, memory optimized or whatever it is. So here we have something for POC, like small kind of purpose, like with 1 GB RAM and ROM, we have something which is actually also a free tier only. So I'm actually going with that because it is just for a demo purpose only. So there are various types of instances you can decide based on your RAM and ROM, based on your applications, and you can choose it. So there are consideration and requirements which actually should map with your resources, and that is how you need to choose it also. And once this is done, of course, I told you like we need to decide on the uh, networking part also. So by default, they provide some default networks being created with AWS. So I'm trying to choose it, but you can create your own virtual private, your VPC, and under that you can design the subnets. So there are so many designing, architecting way which we need to take into consideration when we are trying to launch it on a secured level. As of now, I'm going with the default settings itself. And next is like on based on the operating system we have chosen. Next is a storage, how much storage we require, we need to choose it. As of now, it is 30 GB by default is for this kind of instance they are giving. So for me also it is enough for 30 GB. And this is actually a kind of the C drive and D drive which is actually defined. So when I try to add new, it will actually add it as a kind of a D drive or something only. So this is how we can add multiple volumes also for different things, and how much ever you want size also you can mention it here itself. And even after creating the server also, you can attach volumes, like you can attach your D drive or E drive easily just in a second. So that efficient it is. And next is like your security group. So security group is a kind of a firewall. So as of now, I'm trying to choose which I've already created. So here, as of now, I am opening it to public, like to over every complete IP range. Because it is a kind of a demo only, I will terminate it after it. But we need to make sure like where it all need to be open, what are the IP ranges that can access our application or access our server, all needs to be defined, and what is the port which needs to be open for your application, what kind of a protocol, everything in kind of networking comes into picture. So cloud is something like you're going to involve everything into one picture. That is an end-to-end perspective, like from your applications, operations, everything comes into picture here. And once this is done, you can just review all your details, whatever I have chosen, and then you can launch it. So while launching it for security purposes, you can try to create a new key pair. This key pair is useful to generate your password for your Windows machine. So as of now, I already have a key pair generated for my old missions. So even that key pair also I can use it. When you're try to log in for the first time and use it, try to create a new pair and download. And for the upcoming servers, you can use the same key pair, because this key pair is important to have it with you to generate your password for your machine. So make sure you have it with you. So I'm choosing this test key pair as my key pair, and I'm going to launch it. So launch it. It has given a unique ID for your instance, and it is actually launching up. So this is just, it will take some 2 to 3 minutes at the maximum, and your complete mission will be ready as fast as possible. So it is that much efficient to use the resources, because just think, see, it was like pending state and now it has been changed to run state. So it is that efficient and that fast you are able to get resources accessible. So once this is up, this in a status check should actually come up to completed, so that you can access the server. So below is a list of all the details about or whatever about the instances, like what is the type you are using it, what is the IP of you. Every server will actually get assigned with a private IP, and as I have given a public IP required when I launched instances, assigned a public IP also. So using this public IP only, I will be accessing the server, and under what virtual private cloud I have created, under what subnet. So as I have given it default, it has created on the default thing itself. And when I have launched it, what is the keeper I have used it. So various details you can get it here. Your volumes, like if, for example, your D drives or C drives will be getting listed here. And what is the kind of an image, like images, like even for your laptops, you have your images being set up. Every operating system is being installed via some images only. So same way here also we go for images. So once your server is up, now what we can do is we can try to generate password for your server. So it is still launching, we need to wait for some more time. So in the meanwhile, I'll just show you what are the different services with respect to the server. So as I told you, we have something called as volumes here. That is all your C drive and your D drive for your server to be attached. So usually by default, I have now created one volume, which is 30 GB, which is actually my operating system volume. That is your C drive. So at the instance itself, I can easily create a new volume and then attach it to the existing instance also. That is also possible. So for example, I can choose some 5 GB only I require, and then which availability zone. So availability zone is something I actually missed before. So availability zone is nothing but, as I told you, like we have different regions here. So in every region we'll have different areas called as availability zones. Like for example, when it is North Virginia, inside North Virginia itself, we'll have something called as 6 to 7 data centers placed some miles apart. This is all for disaster recovery, as I told you, for disaster assistance they have set up. So, and also for the latency purpose. So we can choose the availability zone based on which place your instance is actually launched. So if you see, if you here you can choose your availability zone snapshot. If there is anything you can choose, or else you can leave blank, and then you can create it. So once you create it, you can again go to app options, and there is an option called as attach volume. So attach volume you can choose. So it will list all the servers which is at the backend, and you can choose that server. It will automatically get attached to it. So it is just in point of time you can attach and detach your storage for your server also. So when you come to instances, I forgot to show you that availability zone. So here if you see, it will be US, yeah, US East 1E. So this US East 1 actually refers to North Virginia, and this alphabets A, B, C, D, E, this last alphabet shows which data center in that region is actually chosen. Okay, I think the server is completely up. Now we will try to generate the password for it. So let me choose the key pair for it. So this is what I actually downloaded and kept. So you need to choose your file from your downloads and decrypt the password. So make sure you copy the password and keep it in a safe place, because the problem is you cannot regenerate the password again. So make sure like you copy the password and keep it. Your username by default is administrator only. So I have done with the password. So now what I'm going to do is I will actually now launch the mission. So before launching, I'll just try to share my complete desktop so that it will be easy for everybody to view the complete portion. Open it, and you need to give the IP of your server there. I hope that it is actually visible, the remote desktop. If not, please let me know. I hope I have shared it. Okay. Okay, I think now it is visible. Yeah, sure. Thank you very much. So I have given paste the IP and I'm trying to connect to the IP. So I need to give my credentials here. So username is actually administrator, and password I have just copied and kept it. I'm going to paste it here. Okay, I'm trying to log into the mission. Yes. Okay, I have logged into the mission, and this is actually the virtual mission which is actually getting ready, and it is almost done, and it has come up also. Okay, so now our virtual machine is ready. So what we can do is now we can just try to test it and see whether this virtual machine is accessible. So let me give the IP here. It won't be accessible now because I have not created any link. I mean, like I have not hosted anything inside the server. The server is just a normal kind of a laptop only. So in the meanwhile, now we'll create a kind of a host, like for example, to host your applications. By default, Windows is having something called as IIS, Internet. So that IIS service I'm going to install. So via that only I'm going to host a kind of a default page of IIS itself, which can be visible outside, which can be accessible outside. It's loading for some time. as I've chosen a very small machine, actually it is computing power is too low for VOC. It is just a bit slow, else it will be faster only. So you need not worry about the speed. Let me install it here. So which I have, this is the IAS which I wanted to install. I'm choosing it, and once this is done, let me install it. Here also nothing much to worry. So I'll just install it with respect to IAS, whatever services are there. And once this is done, I'm installing it. So this installation might take some 30 seconds, not more than that. So once this installation is done, I'll just show you where the HTML page or whichever is actually visible outside. We can actually see it from external thing also. So as you see outside, this is giving an error, site can't be reached, because we have not set up any service to actually expose your server outside and host any application to expose it outside, which is actually now getting ready. So I have just given one example, this IAS. By default it is there, but you can choose your own. There are so many other things called as Apache Tomcat is there, which is actually acting as a hosting for application. So it is all kind of a free only. You can just install it and use it. So this will get installed, and once this is installed, we will be able to have some default files of it. So it actually by default has a kind of a normal default page, which actually which is the location wherein we can also host our applications. So if you have your Java application or your HTML application, you can just put it in that location, that index page. So it will automatically get be browsed via the IP, and it can be externally used also. So it is just the next level from your local host. Every time we try to create an application, use it in a local host in your local machine and just show it outside. But this is going to be your next level of usage, a real-time scenario, like how your application is going to be hosted and showed outside. So via the IPs, we need to know it. So installation is succeed. So once this is done, I'll let you show you where it is actually stored. Okay. So inside this, if you go to your C drive, so as you saw, C drive 30 GB, it is there. So inside C drive, this inet pub is the folder which got created because of this ww root. So this is actually the HTML page. So this HTML page by default they have created. So this is actually the HTML code they have given for that page. So now if you see, when you try to access it, will be accessible. So this page is what is the page which actually is shown here, with all your HTML tags and everything which is being mentioned here. So in this location, you can even set up all your application code, application pages and interlinks and everything here, and you can access it via this IP. So this is how simple and how efficient we can actually use cloud. And actually this is just one service which I've actually told you. There are many other list of services for database. If you are having your application with database, you can install it on the same server itself, or if you wanted to have something separate, you can even choose the database RDS, because RDS is going to have a list of all different databases, like PostgreSQL is there, MySQL is there. They have their own kind of customized DB also. So whichever you want, you can actually choose it, and it will actually, once you create an RDS, it will give kind of a URL endpoint kind of thing. So that endpoint you can actually put it in your application and you can connect it to that. Like how you normal do your ODBC connectivity, you have for ODBC connectivity, you will just mention like localhost and everything. Here you will get a kind of a URL which is publicly accessible based on the accessibility rules you define in your database, and you can configure that in your code, in your database code, in your application. So it will automatically connect to your database here. So this is how efficient we have these things in picture. So this is all I wanted to actually give a small gist about cloud, and a very small idea about AWS cloud also. So I hope it was a very useful session. and it will be good like if I get some feedback. If there is any queries, please let me know. I have also shared like my email ID and my contact details, so if you wanted, you can actually get back to me if you have any queries. I am open to it. So thank you very much for a fruitful session, for providing it to me, so that and getting my knowledge being shared to different amount of people. Thank you very much, R.M.D. College.
Thank you, sir, for sharing a lot of information about cloud computing. Now, this is a questionnaire and answering session. Some of the participants, they have posted questions in the chat box. I read it one by one, sir.
Sure,
First
ma'am.
question is, which cloud is would be better for the students to use, and what are the minimum hardware requirements of the cloud to set up in laptop?
Yeah, ma'am, this is a good question. So with respect to college, it is not like I won't be actually much specific with, okay, go for this cloud vendor alone, because it'll become a kind of what to say, a business kind of perspective. That is why I told you, like, we need to have a list of requirements. For example, how many students are there in your college? What is the kind of a lab setup you wanted to make in college? How many systems you wanted? So for example, in the present scenario, you would have number of systems, and you, of course, for each and every system, you would have defined your hardware requirements, 4 GB RAM, everything. That same configuration is actually available in cloud also, which you can choose in that instance types, and you can create your instance and you can launch it and use this. And there is one more thing called as workspaces also. I'll just show you. That workspaces, I think, might be useful for you in creating a kind of a virtual desktops. So in AWS itself, we have something called as workspaces. So this workspace is a kind of a desktop kind of environment which is provided and accessible via a client only. Like a workspace client is there, you can just log into that and give your user ID, username, password, and you can log in, it will create a virtual. So this can be shared between different people. Like you can create one kind of workspace and you can create multiple IDs and share it. So based on its RAM and ROM capacity, it can be used by multiple people. You can customize your operating system also based on your requirement, and that is how I mentioned to choose which is the good cloud for you. Because sometimes with respect to college I mean, like policies, there are some certain things like, okay, these are the restrictions we need to make it, these are the policies we need to make it, and everything are involved here. So based on that, and based on the cost, what is it, costing which they actually provide, like you try to contact each and every vendor, like AWS or Microsoft Azure are there, VMware also there, Rackspace Cloud, many cloud vendors are there. Try to contact them and try to get their cost based on your requirement, and whichever is suiting your requirement, I will request you to choose it. Because even from organization perspective, we do the same thing, because we won't actually sit with only a single cloud. So based on a requirement mapping and based on the client's requirement, we try to map it with the different vendors. We'll consult with the vendors and we choose the best cost and the best security rules and everything, and then we go ahead and choosing the vendor. So this is how we work out. So one example I have given you is this Amazon Workspace, which is a kind of a desktop experience which can be used for cloud, I mean, like for college students to create a virtual environment and use it. So it is a good way, like instead of purchasing different softwares, you can use these things kind of a bulk and pay based on the utilization. So it is like you can utilize based on the number of hours only. You can even stop this and keep it this virtual desktop whenever you're not willing to use it, and that will actually reduce the cost, because when you stop any resources, we are not going to involve on the running cost. So even for these instances which I've actually created, there is an option wherein I can choose the option to stop and also keep it. So I can stop and even terminate it. So it is based on the utilization again. If you want to use it, make it on and use it. If not, you can just stop and keep it. It is for a safety purpose as well as reducing the cost. Hope I answered the question now.
Thank you, sir. Next question is, what is the key management and security issues in cloud computing?
Okay, so with respect to security management, if you wanted to take into consideration, it is actually a big list of topics which I need to take it. But on a small level, on a higher level, I wanted to tell you is, as I told you, there are some minimal amount of data loss which can happen. But on my complete experience, I have never come across that scenarios. And sometimes, like during disaster, and see, anywhere and everywhere, we cannot assure like all the time it can be up and running. See, for example, even Amazon is having their own website, and this website is also posted in one of the server. There are chances like this can go down even on a best architecture also. There is a very, very minimal, very, very rare case. So with respect to security, I don't think so much things are compromised when we go with on-prem and cloud. So most of the things are taken care as of now. So if there is any specific requirement, like, okay, so this specific security, is it available in cloud or something? Maybe you can go for the vendor specific thing and ask them the queries. Like whenever you create an account, we have supports also, we can create with them. And if there is any queries, you can come back also, like if there is any specific security requirement, so that it will be better to clarify than going for an overall perspective.
Thank you, sir. One more question, sir. Please tell me a real life application of homomorphic encryption technique for data computation that implemented in clouds.
Okay, so homomorphic encryption, these techniques are actually, see, it is actually a top layer of cloud. I would not tell you like it is actually a cloud technology, because cloud is actually the bottom infrastructure which is actually designed. So that is all based on the application which you design on top of it. So with respect to encryption techniques, I would like to tell you, like in services, if you see, we have the security and compliance. We have different kinds of encryption mechanisms they have listed in these things. So it is like we can choose one technique from this one and integrate it with our application based on a requirement and use it. For example, we have their custom key management system, we have certificate managers, and we have secret managers. So there are so many different services. So we need to try to integrate with our requirement based on the need. Because homomorphic encryption, I'm not much knowledge and depth about it, but with respect to that, if I wanted to tell you, so we need to be specific on what kind of homomorphic encryption, how we are going to use it. So is it going to be implemented on an application which you have already have in, and is it available with respect to cloud services which they're actually providing, and how you can integrate it. So all these factors and terminologies can be interrelated, and that is the way you can choose in a better way.
Thank you, sir. On behalf of our department, I would like to thank our management, our principal, for permitting us to conduct this FDP today. And also, I would like to thank our head of the department for motivating us to conduct this event. And I take this opportunity to thank today's resource person, Mr.B.Ekambaram, cloud engineer Philips, for accepting our invitation and joined with us today. Thank you, sir. Thank you so much for providing more information on cloud computing. I hope this FTP is really helpful for all the participants to enrich their knowledge in cloud computing. I thank all the participants for attending this seminar, this FTP, and making this FTP a grand success. And one more announcement for the participants: attendance and feedback link is available in chat box and in description box. Link will be available only for 15 minutes. So make use of that for getting e-certificate. Thank you so much.
Yeah, thank you very much.